and we manufacture energy recovery devices for...
How did the company start,
Yeah, the company was founded a little over 30 years ago, and the primary reason behind that is because desalination is not something that's being done in the US. So within the CO2 space, that's our newest business unit, and that's where we're starting to see some traction now. We've won some awards for product innovation in that space as well.
Yeah, the engineering concept's still the same. Exactly. Is how it'll just go through.
So it's completely driven by the brine flow. There's no motor, there's no electricity. There's only one moving part, which is the rotor here. The downside to that is that as that piston moves back and forth, there's wear associated with that.
You guys operate mostly internationally in the US, what markets?
So we're based in California. All of our manufacturing is done in the United States.
Okay, I'm here with Kadaj with Energy Recovery. Thanks for doing this interview with me today.
All right, my pleasure.
Yeah, so give me a brief overview. What do you guys do?
So Energy Recovery has been in existence for about 30 years. We had our 30th anniversary last year. And we manufacture energy recovery devices for primarily the desalination industry, although now we are getting involved in industrial wastewater treatment, municipal wastewater treatment, as well as CO2 refrigeration.
How did the company start, come into existence?
Yeah, the company was founded a little over 30 years ago by the original founder, who was a Norwegian gentleman who actually created the original pressure exchanger for a completely different application than desalination. But the company was founded and moved to Virginia back about 30 years ago. And ever since then, we've been primarily involved in the desalination space and have really done quite well in that space.
So what are we looking at here? Is this one of your
Yeah, this is one of our flagship pressure exchanger devices. And what this does is, in a typical RO, reverse osmosis membrane system, you have a high pressure pump that pumps all of the flow and all of the pressure through the membrane system. Two streams come out: a permeate stream, which comes out at low pressure, and a high pressure brine stream that, if you don't have a pressure exchanger, you would have to throttle that through some type of a valve to reduce that pressure down. When you implement the pressure exchanger, now that valve goes away, and now the pressure exchanger is essentially a second pump in parallel with the main high pressure pump. The high pressure pump now only has to process 40% of the original flow, because the recovery of typical seawater desalination systems is around 40%. The other 60% is then processed through the pressure exchanger, and that allows the main high pressure pump to be reduced, the main high pressure pump motor to be reduced, and the energy to be cut by about 50 to 60%.
Is there any electricity that goes into this? So it operates itself?
It operates itself. So it's completely driven by the brine flow. There's no motor, there's no electricity. There's only one moving part, which is the rotor here in the core of the product itself.
So can you show me how the water comes in? How does the actual water flow through this device?
Sure. So there's two inlets and two outlets. You have the seawater. The low pressure seawater comes in, and it'll fill one of these channels as the rotor is spinning. Once the channel is full of seawater, the rotor spins, and it's exposed to high pressure brine that comes in through this side, and that high pressure brine then ejects that seawater out through this connection into the membrane. There are no physical pistons in the product itself. It's water on water contact, so it's a water piston. You can think about it in a similar way to a positive displacement pump, just without physical pistons. So once that water is ejected out, now one of these channels is full of brine. So that brine has to go somewhere. That brine is then, the rotor continues to spin, and that brine is now exposed to the low pressure seawater, which then ejects that brine out at low pressure. And then the process simply repeats itself over and over again.
So there's just, like you mentioned, there's just one moving part. Does it wear? What's the maintenance, the life cycle on something like this?
Yeah, so that's the beauty of the PX. The core of the PX, which is the entire cartridge, but the rotor is the most important part. It's made of our own proprietary alumina ceramic. We're completely vertically integrated, where we go from pure alumina ceramic dust all the way through the machining and the firing process to create these internal components. There's no maintenance, there's no downtime, and they're designed to last for at least 25 years.
Wow, yeah, So do a lot of these, you had mentioned that it doesn't have any pistons. Do some of these kind of devices have that kind of mechanical wearing?
So there have been other energy recovery devices that do have physical pistons, very large physical pistons, and the downside to that is that as that piston moves back and forth, there's wear associated with that, and eventually the piston will wear out. Whereas here, there's really nothing to wear. The rotor rides on a very thin fluid film, so there's no contact between the rotor and the sleeve, and there's no contact between the rotor and the end covers either.
That's pretty neat. All right, you mentioned kind of two other applications.
Yeah. Industrial wastewater.
Industrial wastewater, and then your CO2 refrigeration.
Yeah.
I think you also mentioned mining as well.
Mining's
That there, because a lot of these you said end up used with in conjunction with membranes, but you have some applications that's not the case.
That's true. So outside of the water space, outside of the wastewater space, there are two applications that we get involved in at this time. One is CO2 refrigeration. So if you think about a standard refrigerator or freezer, you have a refrigeration process where you are dropping pressure on one side when the CO2, the liquid refrigerant, expands, and on the other side it's compressed. There's no membrane there, but the pressure exchanger works in any process where you have a pressure drop on one side and pumping or compression on the other side. So within the CO2 space, that's our newest business unit, and that's where we're starting to see some traction now. We've won some awards for product innovation in that space as well. So that's just now starting to get off the ground. The mining application that I spoke of is for mine cooling in these deep half-mile and 1 mile down mines. So at the bottom of the mine shaft, it gets extremely hot because the deeper you go into the earth, the hotter it gets. So when you have people working at the bottom of these mines, you have to keep them cool. So there's basically a giant air conditioner down there. It's an air cooled device where you have cold water blowing over this type of a heat exchanger, and that creates the air conditioning. So you have cold water coming down the mine shaft on one side, and once you get to the bottom of the mine shaft, you have a tremendous amount of head that's built up in that pipe. And you can't use the pressure, you can't use the water at that pressure at the bottom of the mine. The pressure is too high. Now on the other side, once the cooled water has given up all of its thermal component, you have to pump it back up to the surface so that it can get cooled again and the cycle can repeat itself. So again, we have a situation where you have pressure drop on one side and pumping on the other side, and the pressure exchanger is used in the exact same way. It's just the fluids are a little bit different, but the theory of operation is identical.
Yeah, the engineering concept's still the same.
Exactly.
Is how it'll just go through.
That's correct.
All right. Do you guys operate mostly internationally in the U.S.? Kind of what markets?
So we're based in California. All of our manufacturing is done in the United States. The majority of our business is outside of the United States, and the primary reason behind that is because desalination is not something that's being done in the U.S. very much. Our largest market is Saudi Arabia. That's where a lot of the desalination is going on. But we're starting to see things pick up in areas like China, India, where there's a lot of water scarcity, there's large population growth, and where they really need water.
All right, neat. Eric, thanks for demoing everything today. This is really great.
My pleasure. Thanks for coming.